In this video, we are going to learn one-step equations with addition. So first we have to go through a few definitions. The first one is expression. And what we're going to do is we're going to compare an expression with an equation. So an expression, we have two types of expressions that we learned last chapter. We have numerical expressions and we have algebraic expressions. Now, numerical expressions, I'm just going to abbreviate, have numbers and operations. So, for example, 2 times 3 plus 4 times 6 minus 1. Just numbers and operations. Algebraic expressions must contain a letter, must contain a variable. So, for example, 2x plus 3y minus 6. That's an algebraic expression. Both of these expressions have 3 terms, and I can count them for you. We have 1, we have 2, 3. 1, 2, 3. They don't have to have 3 terms, but both of them did. Now, the difference between an expression and an equation is that an equation must have an equal sign. So, must have an equal sign. So, it's kind of like an algebraic expression with an equal sign. So, it must equal something. So, for example, x plus 3 equals 10. Okay? Now, expressions, we were only able to simplify, right? We were able to simplify expressions. Numerical expressions, we were able to simplify using PEMDAS. Algebraic expressions, we learned in the last chapter that we can distribute, we can combine like terms, we could do both, and we can also factor. In an equation, we cannot simplify, we can only solve. So our keyword here is to solve. And when I say solve, I'm saying find what does x represent? What is x standing in the place of? Now, something like this is kind of an easy question, and you might be able to figure it out by using guess and check, by using mental math. But throughout this chapter, we are going to find a way, a systematic way to solve for these equations. Okay? And I just did simplify and I just did solve. Now, the way we are going to solve our equations, and I'm going to just write that question that I wrote up there over here. The way our method to solve an equation is to use inverse operations. Okay? So we use opposite operations. And what this does is I like to think of inverse operations as undoing. So it undoes the operation that it shows. All right. So we have 2 sets of inverse operations that we're going to learn now. We have addition and subtraction. They undo each other. So if I take 10 and I add 3, I'm at 13, right? And if I take 13 and I subtract 3, I'm back at 10. Okay? So they undo each other. Then we have multiplication and division. They undo each other because if I start with 10 and I multiply by 6, I get 60. And then if I take 60 and I divide by 6, I get back to 10. So it does the inverse operation. It undoes what we just did. Okay? All right, so we are going to use inverse operations to undo the operation we see to get x all by itself. So our goal for solving is to get our variable by itself. So in looking at this first question, I see x plus 46 equals 72. Now, in order to get the x by itself, right now, the x is not by itself because it has an x plus 46. So what we're going to do is we're going to undo that 46 by using the inverse operation. And it's important to show our work this way because as these questions get harder, it will be easier for us to follow our work and be less confused. So right now I see plus 46. So what I'm going to do is I'm going to subtract 46 on both sides of my equal sign. Here's my equal sign. So on both sides, I'm going to subtract 46. And you could draw that line there if you'd like. Okay. Now, 46 minus 46 is 0. So we have x plus 0, or just x. We would never write x plus 0. Equals, and then whatever this subtraction is going to be our answer. So I'm going to borrow. We have 12 and 6. 12 minus 6 is 6, and 6 minus 4 is 2. So our final answer, x must equal 26. So here's how we're going to check our work. You can always check your work by substituting, replacing the x with a 26 to make sure it works. Does 26 plus 46, that has to give us 72 because that's what our question says. So if I check my work, I get 4, 5, 6, 7. Yep, it worked. Okay, and let's do one more. Let's do example 2. I have d plus 5 equals 53. Now, in order to get d by itself, I must do the inverse operations. I must subtract 5 on both sides. What that does is it gets the d by itself, and we cancel this out on purpose. We're doing this on purpose. We're using the inverse operations to cancel that out on purpose so that we're left with d on that left side. We will always still have our equal sign. And then we subtract 13, 4. So 47. Okay. Oh, sorry. 40. I think I made a mistake. 13, 8. 48. Sorry about that. So d equals 48. And I knew I made that slight mistake because I said, in my head, I said, okay, well, I know that 48 plus 5 should give us that 53. And when I did it in my head very quickly, I realized it was wrong. So we can always check our work. And this gets me back to 53. Okay. This last question we're going to do here is a word problem. Sophia builds 7 model airplanes during the summer. At the end of the summer, she has 25 model airplanes. How many did she have before the summer? So I always like to map this out. A few things we must do. We must define our variable. So I'm just going to use x because we like to use x. And our x is like our question. How many model airplanes did she have before the summer? So the amount, so x is going to stand for the amount of model planes before summer. So we have the one she made before summer plus the one she made during the summer, and that's going to give us the total. Now, before the summer, that's what we don't know, so I'm going to make that our x. During, we have 7, it says it right here, okay, equals our total. Our total, she says, is 25. So we just created our equation. X plus 7 equals 25. Now, to solve our equation, we subtract 7 on both sides to find out x equals 18. Okay? Now, you would never say x equals 18 to somebody, right? That is our answer to our equation, but we should write a little sentence. Sophia made 18 model airplanes before the summer. And that is our final answer.